Our next speaker comes to us from Adidas. He's one of the iOS leads there, and what interests you? And I thought he'd say, AI or no, Brazilian barbecue. Please welcome, speaking about modular at scale. Here's Eduardo.
So yeah, today we're going to talk a little bit about how we structure the modules in Adidas. It's not going to be too much about code. It's more like the concepts and practices we used and kind of the mindset behind how we started modularizing things. Quick overview of who am I. So basically, I'm from Brazil. I'm from a very, very small town. And I lived a lot on Minas Gerais, the state of the pão de queijo, the Brazilian cheese bread. And in 2021, I basically took my wife, my dog, some bags, and my cat, and moved to the Netherlands to be one of the iOS leads. Initially for the Confirmed app, which is one of the apps in Adidas. And then later, as things changed, I started doing a bit of all apps. So I'm all around the mobile space. And main idea is to talk about the problems we had, the architecture we introduced, and the mindset and results, and maybe how you could bring that for your own space. Starting with the problems, first, a bit of context. So Adidas is huge. We have monorepo. Actually, we have several monorepos. Today, we're going to talk about one with the main apps. And it's also everywhere, so we have different markets and different specific things based on the market. And also the foundational code is mostly shared. We also have like a huge coordination challenge because we have several teams, and most times we share the engineering resources in different business units, which is tricky. And also, one thing that may not feel that much is that almost every feature is attached to some sort of physical product, and they have specific dates to be launched. So if we delay something on the release, we might have to delay the physical product, and that's not optimal. Some problems we had were related to this, like several teams on the same code base. We had like the regular, like the code conflicts, the formatting discussions, the approach file. We also had like different decisions on people would like, hey, I'm going to use TCA, I'm going to use MVP, MVC, nothing, and so on. Quality was also something tricky because one team would say, yeah, we're going to do it when we have time. The other team would say, I don't write features without code. And sometimes no one had time because product, yeah. Test, not so nice. Give me the feature. And we also had several breaking changes since the app is not done to like be shared at first. After we joined everything, if you change one thing in one app, it might break the other, and so on. And we also sometimes had no reuse. So PO would just say, hey, Confirmed has this feature. Bring it to the Adidas app. But is there just a small change? It should be easy, right? Just bring it to the app. But then, since not everything was thought through for that, we would do hacks, rebuilds. Sometimes was easy, copy paste, and so on. Another thing is like the tooling. So Confirmed had some tools, Adidas didn't. But devs, QAs, they would work on both apps. We also had the same issue with features. So a feature that was supposed to be ready for both apps, you might have had to cut corners, and then it's not ready, and it would take extra time to be on the other app. And tech debt everywhere. So basically, lots of teams, same code base, alignment not the best, pure chaos. And it doesn't matter which architecture, which thing we would use, if this communication, this sync wouldn't be working well, everything would repeat again. We Also had the problem with the builds, and here I'm gonna just put some notes of what happened. Like last year, we had a talk from Rafa and George. They're sitting in front of me, more or less, and they were talking more about the builds and what they used and the solutions. So the main problems were like we had builds 20, 25 minutes, even on M1. A small code change would trigger like full rebuild, so it could be even worse than this 21 minutes, this 25 minutes. The solution at the time was like, let's request M2s, M3s, and so on. And developers were taking a long time to handle this. And also, if you connected something with another thing, it would just make the build even worse. And in Rafa's words, if this happens, the developer will be sad and we're going to spend a lot of money. Some of the solutions, first one was we introduced Twist, and with Twist it came the caching. So from the caching we would basically don't rebuild whatever is already cached and didn't change. And the other part also with Twist was we had some sort of code workspace generation, we had Xcode gen, and we had some modularization, but the focus was not in builds, was just fix the conflicts. With Twist, it gave us even more power, more control, and Swift code. The results from that were basically projects were opening way faster. The PR builds went from 20 to 25%, 20 to 25 minutes to 8 to 10 minutes, so way better. And this was all focused on the build itself and changing the build system. We were not even thinking about the code change itself or modularization or anything. Just get what you have, put on the build system, and this should help a little bit with caching. So we could think like Twist plus magical caching. Yeah, maybe we solved everything. But yeah, maybe not so much. So no, we didn't solve everything. We still had the other issues, the, let's say, non-coding issues, which was basically we had the modularization, but no clear boundaries and ownership. The team coordination was still messy, so features would still, that the code changes would still break the other teams, and features would not propagate. Each team would be using one architecture. The cross-team dependencies, so again, everything was breaking again. If you don't know what's happening, so change confirmed, and you break China, that has nothing to do with it. And then same thing, like duplication is still happening. The tooling, same as the features, not everywhere. And also the tech debt, still accumulating a lot. So this also adds up with product pressure. So product would say, just give me the feature, I need it. And you're like, but we need some time to do foundational code and to do these changes. And basically what we needed was somehow get this foundation and the ability to adapt and find a way to make the things better connected. So, like I said, to achieve the team independency with some consistency, we also needed a clear ownership of everything. We needed some sort of adaptable architecture to be an enabler for the team to be autonomous and don't really depend on the other one. And we also solid foundations, like balancing whatever the product needs and with whatever the tech needs. And main goal of this architecture itself was we need to have somehow freedom for the teams without all the chaos. The architecture itself, like I said, it's a modular architecture, and what is that? Like, if you get to the Lego idea again, like you want self-contained pieces, small pieces, you connect one with the other, and they should work by itself, and easy to change if you need. And this should help you with the flexibility, the builds should get better, and help with the scaling of the teams. And what do we see as a module? A module is basically the sources, so the code itself, the resources like JSON, localization, assets, and so on. The tests that you, of course, as resources, you might have resources or not. The tests that you may or may not have, depending on which type of module you're building. And ideally, sandbox apps when we can. So make it a way that you can do like the small features and just build a small piece of the app, like the talk before. And along with that, we also introduced the concept of interface or contract modules, which are basically like a blueprint for whatever you're doing. So only the contracts, which means the models, the protocols, the main method signatures, so the public API itself. In this example, we have analytics core interface. The name will make sense a little bit later. But this interface has like the base event, the dispatcher protocol, and the destination protocol, whatever you're going to get your event to. And important thing about this concept is that you should put there whatever should change less. So if something is not going to change, it's very stable, most probably it could be in the interface module. But why is this important? Like we said, we had several rebuilds, and if you change one thing, it probably rebuilds the other. From the graph here, you can see like very strong dependencies, like this HTTP client is everywhere. If you do a change here, maybe the cache will not work well, and it happens a lot. And then you simply get to rebuild all this instead of just that small change, 2-3 lines. And even with tools like Buck, Bazel, Xcode, and so on, they help with the caching of the modules, but they don't exactly help so much on this, so you need to do a bit on top. And how to solve this? You bring in the interfaces, you put your graph more horizontal, and what this will really change is that if the interface doesn't change, whatever depends on it most probably won't recompile, and only the implementation of that target will recompile if it had changes, otherwise it's going to hit cache. And those, the concrete modules, they would be known mostly where you do the bootstrapping, the linking, or set up your dependency injection system, but not everywhere. And this I'm going super quick, like if you want more details, Bruno Rocha from Spotify, he spoke about this several times. You can check his article on Swift Rocks. It's going to have a really good content. And one more thing about this before moving to the next one is that when should I use interfaces? So mostly you should look at the stability and the frequency that things change. So if your module is very stable and doesn't change much, maybe you can extract the interface and it should help. And some examples are like dependency injection system. You shouldn't be changing the code all the time. So maybe this one you don't need an interface. But whenever you have something that you're still unclear and might evolve, you have several implementations or it's really used everywhere, then you should consider the interfaces. The other module would be then the concrete modules, so whatever is materializing that interface, and that's where the business logic and everything is happening. One advantage of this is since the interface is everywhere and the concrete module is mostly in the close to the main target, let's say, then you're going to have more interfaces than these concrete modules, ideally, or maybe one-to-one. And teams can work. So teams that are using the interface shouldn't be affected by the ones that are working on the concrete one. And this will help with the rebuilds and caching. On that note, what we did to kind of split a little bit, we introduced the idea of types of modules. So the interface you already know, the concrete you already know, and then we bring the concepts of what is the types of concretes. We have UI, core, and experience. I will go one by one. And Why is this important? Is because the moment you have like a clear explanation of which one is each thing, you can create some tooling around them and automate the validation of this architecture. Like you can validate the decisions, you can generate better scaffolding like specifics, you can enforce the boundaries, and even get a better view of your dependency graph. I will show some of these tools later. The first module is UI. So UI basically is UI elements in the sense of this is not exactly like your design system. It's just something you add on top. So a composition of the design system elements or SwiftUI extensions and so on, and things that you will share. We also separated them in types or categories. First one is general purpose, so SwiftUI extensions. Ideally, those should be kind of very universal, and we try to have the rule that they should be used by 2 or more apps. The other one is the domain-specific ones. So in here we have product UI. So whatever is related to the building blocks of something that needs the product context, like the product card or a specific label or button just for product. And that specific ones, which are kind of, let's say, the huge target where you put the common things for that app. But the important part of this is, on this one, you don't need to care about the other apps. Like you can start the assumption that this is only for that specific app, so you don't need to handle other cases, just the specific one. The next one would be core. Core, I know it's a very generic name. We kind of had no better name at the time, but it is what it is. Those are non-UI foundational elements, so building blocks, tools, and where you put the business logic. And some of them that don't change, like I said, dependency injection, they don't exactly need to have interfaces. And we also separated them in types. We have the foundational or essential ones, like foundation core, extending foundation, and like very basic building blocks close to the system, and so on. We have, for example, mobile core, that huge blob where you don't know where to put things, so you just create it and throw stuff there, which we should avoid, but happens. We also have the dependencies. Also, I had no better name for this, and those would be like the building blocks for the building blocks, so the analytics or the dependency injection system and so on, like kind of libraries that are not extracted yet. The domain ones, kind of similar to the UI part, so they will bring some business logic for a very specific area or topic. And the data sources, which will be more or less whatever you do to connect to the backend. The next one is the experience, so the central part of this whole thing, which is where the features will come to life. So it's your screens or flows. And those, the main benefit of them are basically whoever owns this module will own the flow end-to-end or the screen end-to-end. And whoever needs to use this should only know the interface or the public API, and we just connect. Whatever is happening inside is not problem of you that's using, but the person that's building. And I have some numbers there. I can go back later to this, but in total, 99 experience, so more or less 99 flows in both apps. We also introduced the idea of module scopes. This is basically kind of to understand if something fits as shared as or app specific. Like the main idea for shared is it should be used by 2 or more apps. This helps us to avoid trying to figure everything out from start. So if you're really not sure that's going to be used by 2 apps, you don't need to do the generalization from start. And if you do have to do that, then it means that you're going to have to do the configurations and customizations. So when you hook this up to another app, you can just go and set this up. The most important thing about this is then you have more stable interface, and ideally you should prove more value and to really have it. And also benefits, like if you're fixing in one place and ideally, when you fix one module and the other app uses it and it's generalized, the bug fixes should go further, the duplication is reduced. And if you have the app specific, then it's kind of the same case as the UI. So you don't need to care about all the details. You don't need to care about the generalization of customization and setup logic. You can just assume that app and go on. And this also speeds up the process of creating new things and trying new things, because it's very isolated, so you have more freedom. So you can experiment. You don't need to be connecting team A with team B to know if you really can change that part of the code. And if you see in a moment that they could evolve, then you just start doing like the minimum so they could later be a shared module and get this setup part. Maybe you do the setup initials, but you don't do all cases, just the case for that app. And one very interesting example of this is we had the deep linking in unconfirmed. So we had the deep linking in Adidas. Confirmed was just consuming this as a shared module. Then we saw that was not very optimal. So we got this shared module created into a app specific, specializing the shared. The idea we used was super nice. We presented to the team. They liked. And then this module evolved to a shared one and took place of the old one. We just deleted the old code and carried on. And we connect all this with layers. I tried to make it simple so we don't have to cry. Basically, whatever you see everywhere, these 3 layers you should have seen at least once in life. So the presentation, domain, and data. And we added the third one, which is integration, which is basically how we call the glue code, or whatever connects all these layers and all these modules. And I'm going to go one by one now. So the first one would be presentation. Our presentation we mostly do with TCA nowadays. And like all the nice stuff from TCA, like the state management, the testing, everything. And it's working really well for us. And the important part here is like try not to put business logic there. Like if you need to do some sort of close to business logic, it's just a flow, but don't mix domain in here. And whatever you consume here should come through the interfaces of something that's behind domain. The next one would be the domain. Domain is a little bit more detailed, so we have some concepts there, but is the idea of the layer that will contain all your business rule that will consume the data layer and will serve the presentation layer, whatever you need. We split this into some ideas, some concepts. We have the domain model, so whatever model is going to come out of this. We have the repositories, so what's going to connect with the data layer and then transform into the domain models and pass it forward. And then we had more like the more logical components. We have use case, which is basically a wrapper that will encapsulate that function that you need all the time as a single operation. We have the workers that are either a moment, like instead of having use case A depend on B, you just go there and you have a wrapper to connect the dots between 2 use cases and create something more complex, or just a more complex logic that is not a single operation and has no state. And then we also introduced the logic controllers, which are the workers with state. Just another name. And data, basically your backend, so whatever you need to do to call the backend and return your codables and handle error and so on. And the main components there, the data models and the services, for lack of a better name. The integration then comes as the glue code, and it has its specific players. The main idea would be to connect everything, so whatever you kind of do on app delegate or very close to the main target, we call it integration. And then you can create like a specific module or specific modules to handle this, or you just go there and put on app delegate and let the rest cleaner. The components in here are one main centerpiece is dependency injection system. So since you have several modules with implementations and interfaces, you need some sort of tool or technique to connect the dots. At first, we were using SwiftInject, and then lately we have been migrating to Swift dependencies from point 3. It's working really well for us. We also have a navigation system, like a navigation service. So since we have a mix of SwiftUI and UIKit, we made it so we have a way to connect feature to feature, not very manually. So a router. And this is UIKit based, so we have some sort of adapter to bring from SwiftUI to UIKit and view controllers, and then we pass this to the system. And then we also have the idea of the experience entry points, which is basically whatever is going to define how you start your feature and how you connect with the outside world. So the route that's going to take you there, the deep linking logic, the inputs, outputs, and connections. And the next one, I will try to show this in a more of a picture of everything working together. So in this diagram, you can see all the layers. You see that the data is behind the domain. Presentation and integration are consuming domain, because sometimes you need domain logic to take decisions on the integration layer. And the main part of this is that everything is its own box, and goes back to the idea of Lego, so you can compose new features, new tools by using those building blocks. And also, like separated blocks, you can, again, try to work in isolation if you need in a module without affecting the others. If we zoom out, we have the full view of the system, so the experiences are in the center. You have the integration there, also connecting the dots. And in here, we bring another idea, which is the libraries. So whenever you get a module that's very stable, very interesting, and very used, you might extract this out, and maybe even open source. Another important part here is like the build system. We have twist plus custom validation, also connecting the dots. And that's basically how we see everything from the outside. We built some tools on top. I'm going to go super quick through them. We have modules catalog, which is a way to extend twist and express how we are setting up these ideas of the cores and so on, and the interface and concrete. We also have the app-specific module scopes. So we also extended twist so we can show this in a nice way when we're implementing a component. You just pass the scope. We also build a tool to do the graph validation. So in here, each dot, so interface, you have a specific rule that will be applicable to it. Or you have exceptions like, I had to use the blob, so I'm paying the price and I'm showing everyone that I shouldn't be using this. And we also build, like, let's say a powered up makefile in our own client, and some other tools in general. So we have Sentinel to check this with danger. We have the scaffolds that we have been working on, code generation whenever it makes sense, the sandbox apps whenever we manage to get them, and sometimes we have a debug mode or debug screen for specific features when you're developing. Apart from all this architecture stuff, the mindset behind this, the idea of evolutionary architectures. So I read this book some time ago and it stuck with me. Basically, the main idea is you should start simple and evolve when needed, unless you really already know it should be complex. And you should try to prove value and to really evolve. And the architecture should just guide decisions, not like set in stone and dictates everything. Why it's evolutionary is because everything will change, requirements will change, the teams will change, code base will grow, and it's almost impossible to do the perfect upfront design. It might be okay, but yeah, not always. So basically the idea is you start with something that works, and then you evolve as you learn a little bit more. And you should also try to find the balance, like product is always there and you still need to do the core work. And core idea is the systems should be designed to adapt and evolve over time. Like, don't try to figure out everything from start. This materializes on our app-specific, shared, and external. So you start with something specific, you reduce coordination overhead, you iterate fast. Then you might get this to a shared one, and then maybe you can evolve to external, and that means either internal open source or external open source. Keep in mind that maybe you can start already from shared if you really know that it should be shared. So key principles behind all this that you should remember about this concept is like the Conway's law. So you should try to develop everything based on the team boundaries. So you should try to have architecture help you communicate, and communication reflect on the architecture more or less. The Gauss law, which basically says that you should not build complexity up front. So it says that something that's very complex most probably started from something super simple at first and evolved. We have our 2 apps rule to understand if we should share or not. We try to keep interface stable. We keep a look on the architecture health and get metrics whenever we can. And then we also try to work in small incremental changes. We also try to let the design really appear, so don't do like very huge assumptions from start. Work with what you know. Try not to exaggerate from start. And we try to build everything self-contained. Results we got, basically, so collaboration improved, like we have patterns everywhere. The shared modules are helping. We don't rebuild everything all the time. The features are propagating well. We're not like breaking each other's code by small change. And we had some technical wins, which is basically like the interfaces are helping us not to break everything. Dependency graph is better, build times are better, and we have tools to enforce the architecture consistency. So basically this was not just a tech, but also a cultural transformation for us. And how you could bring this to your project? You try to get something that's a big bang, but start small. And that doesn't mean just tech. Look at business too. And you try to see what's happening. Like, is it really going to help your product or team? You let it evolve naturally, so don't need to solve everything from start. And you add some guardrails, so make sure that you're not going to regret it. And you try to make it easy. Like, if you make a very complex tool, maybe the teams won't use, and they should be able to focus on what they really need to do, not learn a new tool. And also always keep an eye on it so it doesn't get messy again. Yep. That's it. Thanks.
There were a lot of questions. A lot of people were interested in this, and we won't have time for all of them, so maybe you can answer some on the Slack. One of the questions, a lot of the questions were practical ones. How do you coordinate all this stuff? Is there a different owner for each? What?
So basically, we try to use code owners, and we have like a very strong internal community. So if we see that something is not going well, we just open a call, open a thread, and talk to each other. With product, is a little bit tricky. Some product owners are okay with these changes. Some others need a bit of convincing. But on the technical part, we basically just talk to each other. We get good communication.
There were questions about how long the restructuring took, how that process went, and did you stop producing new features while you were doing this big project?
No, that's the whole idea of evolutionary architecture. So we try to do those small incremental changes, and we do just enough so we can get to the next step. So we do a lot of phased approaches. For example, the deep linking, we started in a way that we could get each one by one and migrate. So then we had like 100 tasks to change the deep links, and each team would pick one whenever they could. And we also have a thing that we try to attach those technical features to the targets of the people. Like we have the 90 days plan, and everyone should get at least some tasks from that. And this helps us to push product to say, hey, if you don't let me do it, then my performance review will be bad, so please help me.
So a lot of people had the same question, which was, during the migration, you're not then moving everything all at once. You're moving it piece by piece, or?
Piece by piece. So we had like a huge migration to Twist. Brafa worked on this a lot. And then after this change, we do piece by piece. Like we try to do, if it's like a really huge change, we plan it up front. But after the migration to Twist, we were mostly able to do piece by piece and small tasks.
Thank you so much. Please thank Eduardo.